1.48 cubed minus 1 over 1.48 cubed plus 1. Now, it is interesting because you cannot work this question like we normally would. In other words, you're not going to have a single log table that is going to give you the answer. And the reason for that is simple. There is no addition and there is no subtraction in logs, which means that we're going to have to do two different tables. The first table is just going to be applying the power, and the second table is actually going to be solving the problem. So 1.48 cubed means 3 times whatever the log of this is. So 1.48 is like saying 1.48 times 10 to the 0. So I'll put the 0 there. 1.4 on the primary column, 8 on the primary row gives me 170. So when I multiply, 3 times 0 is 0, 3 times 7 is 21, 3 times 1 is 3, and 2 is 5. So I will be anti-logging that. So anti-log of 0.510. So I go to my anti-log table and I look for 0.51 on the primary column, 0 on the primary row, and I get 3.24. So that means I have 3.24 minus 1 and 3.24 plus 1, which is going to give me 2.24 over 4.24. And so my second log table will contain that number log 2.24 over 4.24. Okay? Both of them have a base of 0. Alright? Both of them have a characteristic, I should say, of 0. So 2.2 on primary column, 4 on primary row is 0.350, and 4.2 in primary column, 4 in primary row is 627, which should automatically tell you something. This is going to be or contain a negative characteristic. Alright, so let's see. 0 minus 7 cannot go. I will borrow from the 5, which will become 4. 10 minus 7 is 3. 4 minus 2 is 2. 6 minus 3 cannot go, so I'll borrow. This will be bar 1. So 13 minus 6 is 7. And negative 1 minus 0 is just negative 1. So it's going to be bar 1, 0.723. So I will anti-log that. So anti-log of 0.723 times 10 to the negative 1. Alright. I go to my anti-log table. 0.72 primary column, 3 primary row is 5.28 times 10 to the negative 1, or 0.528, both of them to 3 significant figures. So